5.3 and 5.4 is going to look at trig ratios for angles greater than 90 degrees. So what happens is we picture the triangle as we have already so far. We've always just picture a triangle as sitting in space, kind of just a regular triangle. So that triangle we consider to be in this first quadrant. So in this first quadrant, that is the quadrant where everything is positive, nothing negative can be happening. So we take this and we go, okay, so this triangle here, if I was to drop it down at right angles towards my x-axis, my reference angle is the angle between, this is what I call the terminal arm and the x-axis. With everything that we are doing, everything will be with reference to the x-axis. Okay, so that's going to be a very, very, very important axis for us. Everything with reference to that. So the angle between my terminal arm, so remember, this is like a rotation of the arm where we stick it here at the origin and we're rotating this around. So as we're rotating this around, we're rotating it from the positive x-axis. We began this at last day on the end of the lesson from last day. And a positive rotation means it's heading this way in the positive direction. So heading up from the x-axis. The angle is the angle here. So my reference angle when we're talking about opposite, adjacent, hypotenuse, this is my reference angle I'm talking about. Not the one up here, never that one. It's always between my terminal arm where I'm basically putting the peg here, and then this is the rotation part. Okay, so that's my rotation of the arm, and then this is where my angle is. So that'll be my reference angle for opposite, adjacent, all that stuff. So what we're going to do is we're going to take this and take this exact triangle here and then rotate it around this circle. This circle is called a unit circle, so a lot of teachers will refer to it as a unit circle. You don't have to memorize a circle. You got to memorize what I say at the end of it, which will be the conclusion of kind of the theory that comes from this. A unit circle, the reason why is they consider this radius here to be 1 unit long. So it's all 1 unit long all around here. So it's a unit circle because the radius is 1, so we call it a unit circle. What we do is we look at the ratio of all of these. So if we look at this one, we say, okay, the ratio of this will still be the same idea as opposite hypotenuse will be sine, adjacent hypotenuse will be cos, opposite adjacent will be tan. So it's the ratio of that triangle. We can draw the same triangle and we can make it bigger, so we can make it go up here and then say, okay, that's 45 degrees. So you can see here that maybe is a 30-degree triangle. I can make the 45-degree triangle, I can make the 60-degree triangle. So we're drawing all of our triangles along this circle. What we're going to do is we're going to see a pattern that occurs. So the pattern that occurs is going to be this. Watch. From this first triangle, this one here is my first quadrant. So this is telling me that along this side, this would be x, right? And this would be y. If I'm telling you the coordinate is x, y. If I'm telling you that the coordinate is x, y, then this coordinate here, right, tells me the base would be x and the height of this would be y. And that's a right angle. So therefore, I can use SOHCAHTOA with this right angle triangle. Then from there, I can do all my primary trig ratios. So my primary trig ratios would be y over r for sine, x over r, oh sorry, this is r, the radius is r, okay, for sine, for cos, and then tan would be y over x. So this formula comes from here. If I take the same triangle and I flip it over into the second quadrant. Remember we numbered the quadrants 1, 2, 3, 4. So this is quadrant 1, 2, 3, 4. Okay, and we did that over here on this page here. 1, 2, 3, 4. So we're going to flip it over to the second quadrant. So I'm going to take the same triangle here. I'm going to take it. It can be any triangle really, but I'm going to mimic it so it looks the same, right? So I can have the same angle here. Drop it down straight at a right angle towards the x-axis. Always at a right angle towards the x-axis. This will be exactly the same triangle. So this will be exactly the same triangle, except this is y, right? So if I said that this was the same point, but I flipped it over, then this would make this positive y as it heads up. Because it's heading left, this would be negative x along the base here. Does that make sense? It's negative x. Okay, and my r will always be positive. My r will always be positive. Okay, so then that will get me certain ratios here. So if I take my ratio and I go, okay, well, that's still a right angle triangle, so I can still perform SOHCAHTOA on this right angle triangle. I would do sine of, and I'll just call it theta for now. Okay, theta for now. It's my angle theta. And sine would be y over r, so y over r. Cos would be negative x over r. And tan would be y over negative x. So y over negative x, which would be negative y over x, right? We usually move the negative up. Okay, so then they went, oh, that's cool. So then what if I take the same triangle, whatever triangle it is that I have here, I'm going to flip it over again. So I'm going to flip it over again, and I'm going to take this exact triangle, flip it over so I get the same point. Make the right angle here. This would now be labeled, what would I label this side? That length is going to be negative y. That's a negative x still. We're sharing the x side here, and this would be capital or positive r. Okay. So if I was to do SOHCAHTOA with this guy, right? If I was to do SOHCAHTOA with this one, we go sine of theta would be negative y. So again, my reference angle, look. See how it looks like a bow tie? I call it the bow tie. So it's like, it's always right angles here, so I always clip my bow tie right here, so it's nice and neat. Always right angles on the x-axis, and my angle of reference is always in the center. So my sine of theta would be opposite over hypotenuse, so negative y over r. Cos of theta would be negative x over r. And what would tan of theta be? TOA. From this angle, tan of theta would be TOA. Yeah.
Y by x.
Yes, exactly. And we would cancel out the two negatives, right? I don't need the two negatives. Let's make it just y by x. Does that make sense? Yep. For which one? For the last one? But it's negative y and negative x. So I'll show you the step.
Oh, okay.
And the two negatives will cancel. And yep, we're going to go to y over x. Yes. So negative y, negative x. Yes. Yeah.
On the third, the one above that,
Yes.
is the y over negative x, is the negative not go to the y on top?
Like that right there?
Yeah, the negative's in the bottom, not the other top.
I moved it to the top. Sorry.
Okay.
I don't understand the question. Is that right? Yeah, I moved it to the top. So exact. Yeah. So for fractions, we always said move it to the middle or to the top. Yeah. Is that good? Yeah. Yeah. So move it to the top. Okay. One more time. We're going to flip the triangle over here. Okay. So then we're going to flip this triangle over here. I'll just use purple again because we're pretty close. So I'll do here. Okay, my reference angle is there, always between the terminal arm and the axis. So then we go like this, watch. This will be what? What would I label this one as? Negative y, is that right? Okay, because it goes heads down. That's positive x still here, and this is r. So then help me with the ratios. This would be cos of theta would be, sorry, sine. Why did I start with cos? The sine of theta would be negative y over r. Is that okay? Opposite over hypotenuse. Cos of theta would be x over r. And tan of theta would be negative y over x. Is that, you see where I'm getting those ratios from?
So does R never change?
R never changes. R is always positive. And it's the radius for the whole circle. So with all the r's, they'll be the same r. Okay. So you might be going, okay, what am I supposed to do with this? So this is where they came up. So again, this is all the theory. You're never going to have to prove it this way, but this is where they came up with the pattern. There's going to be a couple things that they noticed from this. They said, okay, this little angle here, that little angle there, if I took this angle and I pretend, so I want you to do a little calculation with me. So what this is saying is that if this angle here is 20, then I'm flipping it over, and I've got a 20 there, and 20, and 20. So this is what it's saying. So I'm just showing you with a number, right? Because sometimes that helps. So it's 90 degrees. There it is. So if I did any one of these ratios, let's just choose one. Okay? So this terminal arm is always from the x up. So what if I did sine of 20? Okay, hang on. And then I compared that with sine of, and my arm starts at the x-axis, so always starts at the positive x-axis and turns around. So this is my terminal arm, so I'm going all the way around till I hit here. So that's going to be the angle I'm talking about. So this would be, so if I went all the way around from here, how much would that big arc be? How much would that be? If I know that this guy in here is 20, how much would the whole arc be? 180 minus 20, so 160. Does that make sense? Because I took away the 20? Yes? Right? So if that's a 20 slice here, and I took away the 20 slice there, we know it's 180, so this is 160 for this whole arc here, for that arm. Yes? Up to there? Okay. Can you tell me how much would it be if I went to this one here, knowing that that's 20? So pretend we're going all the way around to here. What's my little red one going to be? How much is that going to be? 180 plus 20, so 200. Does that make sense? See how I'm getting the numbers from? Because that's 180 here, add the 20. Okay, how about the last one? Can you help me with the last one? So what if I went from the beginning axis and turned all the way around to here? How much would that be? Knowing that that slice is 20, 340. Right, 360 minus that. Is that all right? Sorry. All right, got it? Okay. On your calculators, this is the pattern they found. And again, they came up with this whole theory. If I did sine of 20, I get 0.342. Can you keep that in your head for a sec? Okay. What if I did sine of 160? Is that not the same number? Okay. What if I did sine of 200? Is that the same number?
No, it's negative.
But it's negative. Okay. How about sine of 340? Same number, but negative. So they found this pattern with the ratio is that if you have the same little, we call this the related acute angle, this little acute angle, and you relate it to this bigger angle, it ends up repeating itself. This thing here, we're going to end up graphing. So I don't know in science if you ever see this yet. Have you seen this? It's a sine wave. It repeats itself. These are the quadrants that it repeats. So it gets the same number, then it gets the same number, and then it gets the same number. So what happens is that things that repeat themselves end up having a pattern like this, where if you were rotating around, you end up repeating itself. What repeats itself? Things like waves. Waves go in and out, in and out, in and out. Right? So the waves on a beach, it's tide, right? So you go in, out, in, out. So this becomes some sort of pattern. We look at this in terms of things that rotate, things that have a pattern that repeats itself, that has kind of a maximum and a minimum. Another thing that repeats itself is if I have a bike wheel and you put a stone in it, it goes to the bottom, comes back up, goes to the bottom, comes back up. It's repeating. And when you graph this, it becomes this. So this circular graph where things repeat end up graphing like this, and that's where they get what's called the sine wave and cosine wave, sound waves and stuff like that. We're going to get to this, the graphing of it, in chapter 6. Right now, we're going to do the calculations. So we're going to do a bunch of calculations to learn how to calculate all of these funny angles, get used to it. We're going to graph it in chapter 6, and then we'll do a bit of the application of, okay, what does this mean in terms of repeating? So when things repeat themselves, this becomes a pattern that repeats itself. We call it a sinusoidal graph. Okay, so we're not going to get into all of it yet, but what they wanted you to do is go, wait, that's a pattern. That's actually repeat, repeat, repeat. That's where they came up with the sine wave and all of this stuff. Then they went, okay, is there a way, if I know I'm getting the same answer for every single one of these, right, as long as there is a related acute angle, that's my dot, to represent this little acute angle. So if it's a related acute angle, and that's what we're going to call it related acute angle, is there a faster way that I can calculate all 4 of these knowing only one of the triangles? So if I know this triangle, I actually technically know all of them, right? Because it's a repeated triangle. It's the same one. So then they looked at this pattern on this unit circle. I'm going to show you. So this triangle here is our favorite one because it's in the, we call the all quadrant. We're going to call it A for all. All. All of them are positive here. So this is where every side is positive. All of them are positive. This one here, when I looked at my ratio, so look, y over r, x over r, all the ratios are positive, all 3 ratios. When I look at this one here, and I check and I go, Who's positive here? Well, but these are both negative. Only sine ratio remained positive because it was using opposite and hypotenuse. So the sine is positive here. So sine. Okay, so sine was positive here. All of them are positive here. In this quadrant, that was negative, that was, oh, tan is positive. Tan is positive here, right? So tan ratio is positive. The other two ratios are negative. And then in this quadrant here, who's positive? Only cos. Okay, so I've got all four quadrants. They came up with what's called a mnemonic memory tool, and they called this CAST. CAST, sorry. I lost my color coding. Okay. They call it CAST. This short form, everyone knows it, and they call it the CAST rule. The CAST rule tells you where each ratio is going to be positive in each quadrant, so that way we can do our ratios faster. We find one and we can find the other. We find one and we can find the other. That also means if I find one angle, I know the other angles. So if I tell you it's 20, you know if I flip that into 20, it's 160. Flip the 20 over, it's 200. Flip the 20 over, it's the same thing. So it became this repeat thing where you can find more than one answer faster. They call it the CAST rule. C for cosine is positive. A for all of them are positive. S for sine is positive. And T for tan is positive. So it's CAST rule. We're going to use that a lot. So this is where the ratios are positive. And the reciprocal ratios. So where would cosecant be positive? Cosecant is the reciprocal of, is it sine or cos? Cosecant is the reciprocal of sine. So it would also be positive with the sine. So cosecant, remember, it's the same. Okay, it's the same ratio as sine, except for A over H, it's O over H, it's H over O. So that would mean the same. So reciprocal ratios too. Okay? So that's what this is giving you. This is where things are positive happening, okay, where the ratios are. I'm going to go over this more. We're going to do some numbers, and then we're going to look at the CAST rule. So it's where the positive ones are positive, the reciprocal ones are positive as well. So take a look here. This related acute angle, let's get used to this idea first. So let me chop down the theory, all this stuff that I was talking about. We're going to chop it down into bits, and we're going to try to use it. Okay, so the first thing I need to know is what's my related acute angle, which means what's my dot. I want to figure out what the dot is, and from that related acute angle, I'll find other things. So the first thing, and again, I'm chopping this into little bits, into little kind of thought processes, and then we're going to build up. So for 160, let's draw this. Draw this with me, and then we're going to figure out, you don't have to do it with a ruler. I'm going to use a ruler just so my diagrams don't get too messy. And I want you to just draw a little quadrant. Okay, you don't have to do it with a ruler. You can just do it rough. I'm just going to do it with a ruler just so that my notes don't get too messy. Okay, so again, you can do it rough. Okay, I want you to draw where 160 is, knowing that we always start from the positive x-axis, right? So we're just starting small. We're going to draw it first. Let's get used to the first step of what I was doing. Draw it first, and we're going to draw it over here, 160 from the positive x-axis, heading up when it's positive. I forgot to do a negative one. If it's negative, we would head down. Okay, so positive 160. From here, right, we're arcing up from the corner and 160. We know that a horizontal line is 180, yes? Makes sense? So 160 should be here. How do I know it's not here? I'm going to draw the line in here? No, it's not acute, right? It's more than 90, so draw it somewhere here. Does that make sense? So 160. We're just drawing the angles. Knowing that you start from your positive x-axis, so this is 160. Okay? I'm asking you, read the question, find the related acute angle. That you're going to get used to this word. I'm going to use it all the time. Related acute angle for each of the angles, and which quadrant is it in terms of CAST. So if I go CAST, it's in the S quadrant. We're going to use this. This is going to be our first step when we're answering the questions. draw it, tell me the related acute angle, and then we know it's in the S quadrant. That means that the sine ratios will be positive. All right, so 160. I haven't finished what the question asked, so I know it's in the S quadrant, okay? But what's the related acute angle? So please tell me what is the related acute angle. Related acute angle is this little guy here. Oops. Sorry, just getting another color. So this one here is the little angle between the terminal arm and my x-axis. I frequently call it beta, okay? You can call it RAA, my related acute angle, and then later on I'll be calling it beta, okay? But when we get to the equations, we'll call it beta as well. You'll see some teachers use beta as it. So my related acute angle, so again, I'll use RAA for now, okay? But later on in some of the equations, some teachers use beta because they just call it beta. So my related acute angle, this little guy here, if we know that's 160, is 20 degrees, right? And we're in the S quadrant. We're good. Done. Okay, so that's my first step for some of the stuff we're going to be answering later. So I just want to be able to draw it first before we get into the question. Okay, next one. And next year, again, like I said, we're doing all the same stuff, but we're going to do it in radians. We're going to do it in a different unit. Okay, so here, 220. So draw the arm, the terminal arm. So it starts at the positive x-axis. Starts at the positive x-axis. It is positive 220. So you're twisting it around in the positive direction, which goes here. 180 is here, so it's beyond 180. How do I know if it's beyond this line? What line is this one? How much is this? How much would this be? This is 90, so we know this is 90. This is 180. This would be 270, right? Is it beyond 270? Not beyond 270. You don't have to label these, right? So it's beyond 180, but not beyond 270. So I'm going to draw my terminal arm here, somewhere here. Okay, so this is 220. Okay, and again, you don't have to label this. This is just me trying to help you out, right? So that arm here, starting from the x-axis in the positive direction, is 220. All right? Then, okay, so if it's 220, what's my related acute angle, which is the dot between, never, ever towards the y-axis, ever. Always think the bow tie, it goes this way. So it's towards the x-axis. Never put the dot there. Never, 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 never. They used to make us teach you two ways. It was so confusing. Everyone's like, which way do I throw it, this way or that? So it's much better. They're like, just stick to one. This works for everything. They never make you do the other way again. I'm so glad they took that away. Right? So always, so now I can say always towards the x-axis. Always, 100% always towards the x-axis, okay? So here, drop it towards the x-axis. What's that little angle? If I know the whole thing is 220, so in my brain, I would go, what's in my brain? I'm going to go 220 minus 180. Does that make sense? You don't have to show me that. But if I know that's 180, it's 220. So then my RAA is 40? 40. Stop me if I'm wrong. Okay. Which quadrant is it in? C-A-S-T. So it's in the T quadrant. In the T quadrant. Again, we're going to use all this later on. It's just kind of getting you used to drawing it and knowing which quadrant you're in. Okay. Next one. 310. 310 would be, so starting, which axis do we start on? Always the positive x. Yeah. Beta, some teachers use beta instead of RAA because it's not a letter for an angle, so they use beta usually, beta. I said you could use RAA for now, and then later on when we're doing calculations, I'll switch to beta. Yeah, but this question is just saying what's the RAA, so you can put RAA. Okay? All right, so here, RAA, we're finding that 310, so that's positive x-axis heading in the positive way, so you're going to go all the way up, that's 180. Go past 270, does that make sense? It's 270, right? I labeled it here, 270, and then you got to do a bit more. So do this. Okay, so that's my angle. So this whole thing is 310. What is my related acute angle, which is always between the terminal arm and the x-axis, never the other way, never, ever, ever, ever. Always here between the x-axis, right? My x-axis is the important one. That's the one we're referring to. So what's this leftover little angle there? And how would I get it? In my brain, I would do, in my brain, I would do 360, right, minus 310. I would do that. And again, you don't have to show me that. And you know your RAA is that 50? 50. 50. Okay, and whose quadrant are you in? C. That's it. Right? This is our first step for some other stuff we're going to be doing. So we want to get the first step done. Sometimes after I do these ones, you forget how to do a little angle. 30 is just 30. It's just regular 30. From the positive x-axis, you're just doing 30. I throw this in, you're like, wait, that's it. So 30. So 30 goes here. That's my angle. So it goes till my terminal. What's my RAA? 30, yeah. Sometimes you're like, wait, what's my... No, it's actually just 30. So my RAA is 30. Okay? And which quadrant is it in? A. A for all. A for all of them positive. Okay, so don't forget, the regular little acute angle is regular. Any questions or clarification?